Okay, hi everyone. Let's talk about probability. This is our last section of notes. So we will review next class. I'll take any questions you might have on this, but it's pretty short and sweet. So number one, we're gonna solve some probability problems. So here are the basic steps for it. Number one, you're gonna determine all possibilities in a logical manner so you can count them. And then number two, determine the number of possibilities that are favorable. So we'll call those winners. So essentially what that means is the probability is going to be the number of winners over the number of total possible outcomes. Number of total outcomes. All right, so let's look at this angle as an example and answer these questions that go along with it. So part A, it says if one of the 4 points on this angle, so we have point A, point B, point C, and point D, if it's picked at random, what's the probability that the point lies on the angle? So number one, we want to look for winners. So basically, how many points lie on this angle? Well, A, B, C, and D all lie on the angle. So our number of winners is 4. Then we want to look at the number of possible or total possible outcomes. So how many total points are in this diagram? Well, there's exactly 4. So this is our number of total outcomes. Now, this might be different if maybe they give us the angle and then, for example, they put a point out there and they call that point E. Then we have 4 winners, 4 points on the angle, but 5 total outcomes. But in this case, they're all on the angle. So we get 4 out of 4. And when we simplify that, that means we have 1. Or sometimes we like to write probability as percentage. So that's a 100% possibility or probability here that our point lies on the angle. Okay, now it says part B. If 2 of the 4 points are selected at random, what is the probability that both lie on CA? So CA, or ray CA, I should say. So that's that ray right there. So now this gets to be a little bit not annoying, but you have to kind of go through and you have to list your different possibilities of 2 points if they're all selected at random. So let's say, or let's list out my possibilities. So I could pick A and B. I could pick A and C, or I could pick A and D. If we go on to B first, we could pick B, C, and C, or B and D. And if I pick BA, that's the same thing as AB, so I'm not going to repeat that. And then my last possibility is to have C and D. So now I want to look for my winners. So I'm looking at both points lying on CA. So I have a couple winners here. I can have A and B, that lies on ray CA. I can have AC, that lies on ray CA. However, AD does not. I could have, or A and D, sorry, do not. A does, but D does not. I could have BC, but not BD because D is not on the ray CA. And then same thing with CD. So basically any of the ones with D are not possible. So my winners here are my parts highlighted in green. So that's 3 out of my total possible outcomes that I listed here, which was 6. And I can simplify that down to 1/2, or if I write it as a percentage, that's 50%. All right, one more example here, going along with this angle. If 3 of the 4 points are selected at random, what is the probability that the ordered letters will correctly name the angle shown? So number 1, you have to remember to name the angle. We need 3 letters. And in those 3 letters, we need the vertex in the middle. Okay, now this is going to be the most repetitive part. We have to list, if they were selecting 3 out of 4 points at random, basically I have to list all combinations of 3 points that are possible. So here, I'm going to start with everything starting with A. So I have A, B, and C. I have A, B, and D. A, C, D. A, C, B. ADB. Let me make this a little bit smaller. While I do this, feel free to pause the video and you can see if you can list them all and come up with the same ones I do. ADC. All right, now I list B. So I have BAC, BAD, BCD, BCA, BDC, and BDA. Then I list all my C starting first, so CAB, CAD, CBA, CBD, CDA, and CDB. Then I have DAB, DAC, DBA, I have DBC, DCA, and DCB. Okay, so I listed all my possibilities of them just picking 3 of 4 random points. And now I have to go through and see what winners I have. So I need the winners are going to be if the angle is named correctly. So like I mentioned, we need a vertex or a vertex point in the middle. So anything without C in the middle is not a possibility. So I can cross anything without C in the middle off. Which means I can cross off this whole row. And I have 1, 2, 3, 4, 5, 6. Now let's check to make sure those all work. So I have ACD, that works. ACB though, if you look at the angle, that would be going point A to the vertex C and then back up that same ray. So this one doesn't make sense. BCD works. However, BCA is similar to ACB. So I'd be going the point B in somewhere in the middle of C and A, then to the vertex and then back. So that does not make sense. And then DCA, that one's good, and DCB is good. So I have 4 possible or 4 total winners. And if I count up all my possible outcomes that I listed, that's 24 possible outcomes. So that gives me a probability of 1/6, or if I write that as a percentage, about 16.67. Okay, the last one. A point Q is randomly chosen on AB. What is the probability that it is within 5 units of C? So I'm going to get us started here, and then I'm going to have you answer this question before you finish the video. So what I would suggest is I would write out each number. Okay, so there's each number, and you want to try to find the probability that it is within 5 units of C. So you want to go through, it can be any one of these numbers can be the point. So it could be a point at 4, 5, 6, 7, and so on. You want to find the winners to where that point is within 5 units of C out of your total possibility. So how many different parts on this line segment can your point be at? So go ahead and try that one out and give me the answer for that. Again, I'll take any questions that you might have on this before we review next class.